Hey, Olivia, I hope you're doing well. Um, I went ahead and put these systems of equations in a matrix. So these would be the coefficients of x, y, z, w, and then it's called an augmented matrix because it represents an equation. So you have this like represents the equal sign, and then you have your constant terms. My goal in solving this is to put it in what's called echelon form, where you have a triangle of zeros in the lower left-hand corner. So my goal is to have that all be zeros. And I'm going to use elementary row operations. To get this to be a zero, I'm going to subtract R1 and R2. So I'm going to go ahead and subtract those. Sorry, R1 and R3. R1 and R3. So 1 minus 1 gives me this 0. Negative 1 minus 0 is negative 1. 1 minus 1 is 0. 1 minus negative 1 is positive 1. 2 minus 2 is 0. Because we operated with R1 and R3, we can now replace this with either of those rows. I'm going to replace it with R3, so I get that 0 here. Okay, so I now have this as a 0. We're going to start this being a 0, and then I also want this to be a 0. So I have all zeros in column 1. So to get this 2 to be a 0, I'm going to do 2 times R3 minus R2. So let's double row 3. So I get 2, 0, 2, negative 2, and 4. And I'm just working with my original R3, not with the augmented one here. So I doubled that, and then negative R4, I'm going to subtract it from R4. So negative 2, 0, negative 1, 0, negative 5. So if I do 2R3 and then subtract R4, I'll get these to be 0. 0, 0, 1, negative 2, negative 1. And I have a choice of putting this into R3 or R4 because those are the rows I used. Well, I'm already row replacing an R3 up here, so I'm going to row replace an R4 right there. So let's rewrite my matrix now. Not doing anything to the first 2 rows. R3 is now this one. And R4 is the second one right here. Okay, so again, my goal is to have this triangle of zeros here, getting closer. I'm going to go for this one. It's always good to work on this one column at a time. So I got these zeros here. I want a 0 here. So I'm going to add R2 and R3 to accomplish that. So I get 0, 0, negative 1, 2, and then a 1. And because I want R3 to have a 0 here, I'm going to place this into R3. And then that accomplishes my zeros for that column. So I'm very close now to accomplishing the triangle of zeros here, which again is called echelon form. All I have to do is get this to be a 0. So I'm going to go ahead and add row 3 and row 4. Ooh, Okay, so it looks like one of our rows has canceled out. So if I rewrite it, I'm going to throw this in R4. So put that in R4. So what I'll have is 1, -1, 1, 0, 2, okay. So this is now what is called a dependent system because I had 4 variables, X, Y, Z, and W, and now really effectively I only have 3 equations. Okay, so this is going to be a dependent system, so we're going to write the solution. So these are coefficients of X, Y, Z, W. So what I'm going to do is bust this out of the matrix to write all of these equations in terms of one variable. And I can decide which one it is. I'm going to start by writing the bottom line, which is -z plus 2w equals 1. So there's one equation that relates w to z. Now, because w is the last variable here, I'm going to write everything in terms of w. So this is going to be -z equals 2w, -2w plus 1. So I get z equaling 2w minus 1. So that's what z equals in terms of w based on this. Okay, let's look at the second equation or the second line. The second line I would write as y. So I'm just going to box this so I don't lose track of it. Y minus z plus w equals 1. And what I want to do is write an equation for y in terms of w. So what I have to do is substitute this equation in right there for z, so I can write the equation for y in terms of w. So I'll write y minus z, which is 2w minus 1, plus w equals 1. So I get y equals -2w plus w is -w. I'm going to change this y minus w because we have -2w plus a w is -w, and then plus 1 equals 1. We can see the 1's cancel, so we get y equals w. Okay, that's kind of fun. So now, gotta go to another page. I have my top equation, which is x minus y plus z equals 2. That is from this top line here. And so far I have y equals w, z equals 2w minus 1. That's what I had so far. So I want to write an equation for x in terms of w. So I'm going to substitute in that and that for y and z. So I'll have x minus y, which is w, plus z, which is 2w minus 1, equals 2. So I get x equals w plus 3. Nope. Minus 3. Nope, plus 3. Wow, that was a whole journey. Okay, so brought the w over to the other side, became positive, bought the 1, that's a 3. So this is our dependent set of equations. X equals w plus 3, y equals w, z equals 2w minus 1, and w will equal itself. So this is the solution. They are dependent equations because you really only have 3 independent equations and 4 variables, so that will not have a unique solution. And this is what we get. I hope that helps. Bye.